Hi everyone, welcome back to the channel. This question is from IIT JEE Advanced 2024. I just learned that very few students got it right and many students found this difficult. I'm just going to show you how simple this problem is. And if you have the basic concepts right, then these kind of problems you will find it super simple to solve. And these are actually high scoring questions. You can solve these questions with score really high. Very simple problem. Not much here. In fact, we just need one equation and I'll show you how to solve this under 2 minutes or 3 minutes. But let's just get to it and understand what's going on. So the question is saying there is a disk of mass m, radius r, free to rotate about its vertical axis. And there is another disk which is attached to a motor which is attached to the bigger disk. So let's draw the diagram to understand this question a little bit better. So I will just draw the diagram from the side view. So basically if you're looking from this side, so how would it look? So we have this one is the bigger disk. Okay. And there is a small motor here. Let's say some motor. And there is some axis here. It's the axis of this motor. And on this shaft, there is another disk which is attached, okay, like this. The mass is m here and here also for both the disks. Mass is same. Let's call this small disk and let's call this bigger disk. And the axis of this disk is like this, right? Okay. Because the motor has been started, so this disk starts rotating like this. So the question is asking what is the omega for this disk. But first you need to understand why would this bigger disk rotate. So let's look at this whole thing a little bit closely. The omega is the speed, angular velocity for this one, this smallest disk. So when this disk is rotating, you know that the angular momentum is defined as I omega, right? So for this disk, omega is in this direction. This is the direction for omega, unit vector, correct? Now, if this is the direction for angular momentum for this small disk, then we must have an angular momentum from this disk also, if suppose there is no torque in this direction. And the torque, because of weight of this small disk at this center, is going to be in this direction. Let's say this is Z direction. So let's name them. Let's say this is Z. And let's say this is Y. This is also Y. So because of this weight, there is a torque in this direction like this. So it will be in Z direction. And same thing, because of the weight of this bigger disk, the torque here in the center of the smaller disk is also going to be in same direction. So effectively there is no torque that is acting in the Y direction. So we know that torque in the Y direction is 0. And if this is the case, then angular momentum in the Y direction is going to be conserved, constant, or total sum of angular momentum should be 0. Okay. So that's it. The problem is more or less solved here. Now, if this small disk is rotating with omega, the angular momentum because of this small disk is I small and omega in Y direction. And so what do you think, which direction this disk should rotate to counter this angular momentum in the positive Y direction? So we should have another angular momentum in this direction, negative Y direction. So therefore this disk should rotate like this, let's say with bigger omega. And hence this will cancel out the angular momentum in this direction. But don't worry, even if you don't do this, even if you take, let's say, omega in big this direction, the opposite direction, eventually you will get the omega with a negative sign indicating that the direction is opposite. So it doesn't matter, but let's say we take it in this direction, opposite. So what is the angular momentum because of this disk rotation in this Y direction? This is I, let's say B, and omega. B is for the bigger disk. So now we know that since torque in Y direction is 0, therefore angular momentum in Y direction is so conserved. total sum should be 0. So Ly is I for smaller disk and omega, and minus I for bigger disk and bigger omega, minus because we have taken this in opposite direction. That should be equal to 0, and Is is nothing but half m r by 2 square omega, and Ib is half mr square plus mr square, because we need to take this mass also, and omega equal to 0. Therefore mr square by 8 omega minus 3 by 2 mr square omega equal to 0. Therefore omega is nothing but omega by 12. Therefore n that the question is asking is 12. That is the answer. So as you see, there was nothing in this question. Pretty much you wouldn't even require pen and paper to solve this problem. But I've seen that over the period of time, IIT JEE advanced level has been asking question which requires a little bit of thinking, and then just one or maximum 2 equations and you will be able to solve the problem. But the moot point is, the core point is that you need to get the concept right. And that's the goal of this channel. My job is to impart basic concepts so that you score much higher in IIT JEE or any other engineering entrance examinations. Thank you very much. Thanks for watching. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.